Good morning. Today we are finishing up our fourth unit. Our last lesson is on mathematical modeling and variation. The first thing that they talk about is linear regression. Linear regression has lots of different names. It could be line of best fit. It could be least squares regression line. What you're really trying to do is find the line that would best go through a set of data points. So they will give you something like this. They're giving you the year and the population. And they're giving you actually the equation of the line that approximates the data. Notice that they're using t between 3 and 10. Usually when they're doing years, they like to use just how many years since a certain date. So in this case, they're using 3, 4, 5, 6, 7, 8, 9, and 10 for their x values. So what they will do is they will plot the data and the graph on the same line. So if we look at this, it is actually plotting the data and the equation of the line. Notice that you can see that line goes through most of the points. But if you look up here, this one's not quite on that line, but it's a very good approximation. It is a very good fit for the actual data. Now, so again, like I said, the least squares regression line of best fit, linear regression, all of these are kind of the same thing. So when we looked at that line, we could see that by visually plotting the points and drawing the line, that it looks like it's probably the best one that you could get. You can actually get the correct equation for a linear regression by using a graphing calculator or your computer. If you look at this announcement, I have attached a link for the Desmos linear regression calculator. So when you talk about linear regression, you usually talk about correlation. Correlation is what they call the R value. It's how close are those points to the actual line. And the closer they are to one and -1, then the better the fit. So notice the absolute value of R is equal to 1. So if you have an R value, say of -0.99, that is very close to being 1 if you do the absolute value. The negative is really just telling you it would have a negative slope. So your data points might look something like this. If you have an R value, let's say of 0.97, again, it's a very strong correlation. But this time our slope would be positive. So you might have a data set that looks like that. So correlation is how strong of a relationship do those points have. The second part of the lesson is on variation, and there are different kinds of variation. The first one we're looking at here is direct variation. So all of these statements are congruent or the same or equivalent. So it says y varies directly as x. Y is directly proportional to x. So the way you look at the equation is y equals k times x. K is what they call the constant of variation, or the constant of proportionality. So it is a constant, it is a number or a numerical value. You can also have direct variation of the nth power. So it says y varies directly as the nth power of x. So again, we are coming up with an equation here, and this one says y equals k times x to the n. Again, k is a non-zero constant. The next type of variation is inverse variation. Inverse, think of division. So it is your constant k divided by x in this case. So y varies inversely as x or is inversely proportional to x. So your inverse is division. The next one we're going to talk about is joint variation. If something varies jointly as two other variables, that would be multiplication. So again, you would just have two variables here instead of just the one. So we have z equals k times x for some non-zero constant k. Again, k is a numerical value. So you have linear regression and different types of variation in this section. If you have any questions, please make sure that you email me, and have a great week.